Hi, everybody. It's Professor Mitchell. We are continuing with Chapter 9. And in this video, we're going to talk about conducting a hypothesis test for the mean, where the population standard deviation is unknown. We started working on this in the last video. And in this video, we're going to talk about the critical value or rejection region approach. So here's our copyright notice that for some reason does not appear in every single one of these PowerPoints, but moving right along. This goes with the assignment that you see here. And the objectives in this section are to conduct and interpret a one-mean hypothesis test using the critical value approach, that should say, with an unknown standard deviation, and make a conclusion and interpret the results of a one-mean hypothesis test, again, where the population standard deviation is unknown, using the critical value or rejection region approach. So to review the steps for conducting this type of hypothesis test, first we're going to choose our null hypothesis and our alternative hypothesis. We're going to decide on the significance level, which in a statistics class will usually be given. We're going to calculate the test statistic, which is the t-score. We talked about that in the last video. And that calculated test statistic is denoted by t sub 0. And in this video, we're going to use the critical value approach, which means we're going to find the critical values that will help us to determine whether or not to reject the null hypothesis. And we always end by interpreting the results. So here's an example. Statistics students believe that the mean score on the first statistics test is 65. Their instructor thinks the mean score is higher than 65. So he samples 10 students and obtains these scores. This data has sample mean 67 and a sample standard deviation of 3.1972. Now, if those sample statistics were not given, notice that you could easily calculate them. You know how to find the mean of 10 numbers, and you know how to find the standard deviation. If you don't want to do that by hand, you can use technology, for example, Excel, and hopefully later on I'll have the opportunity to show you how to do that. Assuming that the scores are normally distributed, we're going to conduct a hypothesis test at the 5% significance level. All right, so the first step is to choose the null hypothesis and the alternative hypothesis. So remember that the instructor claimed that the mean score was higher than 65. So that would automatically be our alternative hypothesis. And then the student's claim would be the null hypothesis. It's kind of unusual, and your book doesn't seem to put a lot of emphasis on this. Usually in a hypothesis test problem, there is only one claim, and that kind of helps you decide how you're going to word your interpretation at the end. So this is a little unusual because the students are claiming one thing and the instructor is claiming another thing. But at least we know that the alternative hypothesis always contains either a greater than, a less than, or a not equal. And so the instructor's claim definitely fits the greater than situation. That greater than sign makes this a right-tailed test. So that's going to be important later. Next, we're going to decide on our significance level, which is called alpha, and that was given in the problem. It said to perform the test at the 5% significance level. That means that alpha equals 0.05. In step 3, we're going to compute the test statistic, t sub 0. Here is the formula for that we talked about in the last video. So notice the things that go into this: the sample mean, which was given to be 67. Mu sub 0 is the number that appears in the null and alternative hypothesis, sometimes called the hypothesized mean. That's 65. S, the sample standard deviation, was given to be 3.2, and N equals 10. And I want to point out that the population standard deviation was not given, so we need to treat that as unknown. That's why we're using T for the test statistic. All right, so over here we have our formula. We're going to put in all of our numbers. You should try this on your calculator and make sure that you get 1.976. All right, so now we're going to find our critical value to help us decide whether or not to reject the null hypothesis. I say critical value and not values because this is a one-tail test. It is a right-tail test. That means there's only going to be one critical value. And while I'm here, I think it might be a good idea to draw a little picture of what this critical value is going to represent. So because this is a right-tail test, we are looking for a value of T that will cut off the top 5% of the T distribution. Okay, so we get that value out of table A3. Now they've gone ahead and provided this little part of a table, but do go ahead and look at your table A3 to make sure that you can find this number. Because our sample size is 10, that means the degrees of freedom is 9. Remember, degrees of freedom is n minus 1. So we're going to go into table A3. We're going to go down to the row that has 9 degrees of freedom. And then we're going to go over to this column right here. So on table A3, well, let me pull it up real quick. Why not? Let's see. Okay, so here's my table A3 right here. So if I go to 9 degrees of freedom, and on your table it's the fourth column. We're looking for area in one tail is 0.05. So if I go down to 9 degrees of freedom, there is that 1.833 right here. All right, so going back to this, there's our 1.833, so that is our critical value. In my picture, it would go right there. All right, so now, hang on, I need to get my mouse back. There we go. All right. Okay, so interpreting the results. Actually, we're going to do that later. They decided to go over all the interpretation at the end, but then they actually did go ahead and interpret it at the bottom. So we'll see it again later, though. Because this is a right-tail test, if the test statistic is greater than T sub alpha, we will reject the null hypothesis. So remember that this region here is called the critical region or the rejection region. If your calculated test statistic comes out anywhere in this region, that means reject the null hypothesis. So that's exactly what's happened here. Our calculated test statistic came out to 1.976. Our critical value is 1.833. So at the 5% significance level, we're going to reject the null hypothesis, which was that the mean was equal to 65. And the interpretation would be something like there is sufficient evidence to conclude that the mean score is higher than 65. So the instructor was right. Okay. All right, next. According to a research study, American teenagers watched 17 hours of television per week on average in 2004. A random sample of 16 American teenagers was surveyed, and the mean amount of time per week each teenager watched television was 15.5 hours. This data has a sample standard deviation of 2.5 hours, and we're assuming that the scores are normally distributed. And they want to know, what are the first 3 steps to performing a one mean hypothesis test at the 10% significance level to test if the mean amount of time American teenagers watch television per week is different than the mean amount of time in 2004. Okay, notice the word different. All right, so the first step, the null and alternative hypotheses. Because the claim is that the amount of TV watched is different, that makes this a two-tailed test. The alternative hypothesis is that mu does not equal, that should say 17. Give me just a second here. All right, so many silly typos in these things. All right, the alternative hypothesis is that mu does not equal 17. The null would be that mu does equal 17. So the status quo, as far as we know, American teenagers watch 17 hours of TV per week. The significance level is 0.0. So now we're going to calculate our test statistic using this same formula, just kind of looking around and making sure there's no other typos. 15.5 minus 17, and then we're going to divide by 2.5 over the square root of 16. And that does come out to negative 2.4. All right, so now we need our critical values. Notice this time I said values. This is a two-tailed test. So our critical values are going to look like this. Here is our t-distribution. So we're looking for 2 t-scores that cut off a combined 0.10 off the 2 ends of the distribution. So 0.05 here and also on the right side. Okay. All right, so we have a piece of table A3 here. Piece of table A3. On your table A3, there are 2 rows at the top. One of them talks about the area in one tail, and the other talks about the area in 2 tails. So you could use either one. You could either look at where it says area in 2 tails. The area in 2 tails would be the whole 0.10. Or you could take area in 1 tail, and that would be 0.05. So on this table, I lost my mouse again. There we go. We're going to look in this column, and because the sample size is 16, that means we're going to look at 15 degrees of freedom, and our critical values are going to be positive and negative 1.753. Okay. Okay, there we go. Sometimes when I use the drawing tool or write text, my mouse disappears and I sometimes have a hard time finding it. So my 2 critical values are plus and minus 1.753, which is a little different from what they got. I think they, I think they looked at the wrong row. They looked at 14 degrees of freedom. All right, so I've gone ahead and fixed that. The critical values are plus and minus 1.753. And because our calculated test statistic was negative 2.4, that would be way out here in the critical region. Okay, so this would be a reject the null hypothesis. Now, when I first looked at this, I noticed that the interpretation was not here, and the interpretation is really, really important. So I went ahead and put it in, and then I noticed that they seem to be putting all the interpretations until the end. So you'll see this a second time. So my interpretation is there is enough evidence to conclude that the mean amount of time American teenagers watch TV differs from 17 hours per week. All right. So now I think we're getting ready to talk about interpretations. Okay, so again, reviewing the steps, choose your null and alternative hypothesis, decide on the significance level, calculate the test statistic, find the critical values, and then do the interpretation. When we have made a decision about the null hypothesis, it's important to write a thoughtful conclusion about the hypotheses in terms of the given problem scenario. So they give you this advice, which is pretty much the same advice that my other textbook uses, that the wording of your conclusion should depend on what the original claim is. Now, I think that's a little tricky. I'm especially thinking about that one problem with the statistics class claiming that the mean was 65 and the instructor claiming something different. So I won't be super picky about this if you're doing it for me. Hopefully in your homework problems, there's just one claim and it's a lot more clear. But if the claim is the null hypothesis, and you've heard this before, by the way, the conclusion is one of the following. If you're rejecting the null hypothesis, the conclusion is that there is enough evidence to reject the claim. And if the decision is to fail to reject the null hypothesis, then the conclusion is there is not enough evidence to reject the claim. Okay. However, if the claim is the alternative hypothesis, then the conclusion is going to be either you reject the null hypothesis, in which case there is enough evidence to support the claim. And if you're failing to reject the null hypothesis, the conclusion is that there is not enough evidence to support the claim. Okay, so example continued from the beginning of the PowerPoint. This was the one about the statistics class. All right, and we did this before. Okay, that was where the test statistic was 1.976, which was greater than the critical value of 1.833. So at the 5% significance level, we can reject the null hypothesis. There is sufficient evidence to support the claim that the mean score is higher than 65. So they're wording their conclusion in terms of the instructor's claim. All right, and then the other example with the teenagers watching television. The researchers continue their hypothesis test about American teenagers watching television by finding critical values and making a conclusion about the null hypothesis. And so the interpretation, which you already saw mine, theirs is a little different. At the 10% significance level, the data provides sufficient evidence to reject the claim that the amount of time that American teenagers watch TV is 17 hours. So they're basing their conclusion on the idea that the original claim was that American teenagers watch TV for 17 hours a week. All right, one more example. Researchers gathered data from a sample of 10 patients to test their claim that the length of time patients wait between dentist visits is less than 180 days. They collected the proper statistics and started working through the testing procedure. So because their claim is that patients wait for less than 180 days to see the dentist, that would be the alternative hypothesis. Your book has not given super clear guidance on, I mean, they're not very consistent. Sometimes they write greater than or equal for the null hypothesis, and sometimes they just write equals. Either one would be okay, all right? Alpha equals 0.03. Now that is an unusual significance level, all right? So I want to get back to that in a second. the test statistic is this formula that we're using before. Now, they have not given me the sample statistics, X bar and S, but that's not really the point of this problem. They just want to see, can I reach the correct? So they're asking us to take their word for it that this test statistic came out to negative 1.82. And they're also saying that the critical value is negative 2.15. That I do want to talk about, okay? Because if you ever find yourself in a situation with one of these unusual levels of significance, let me show you the problem. What this critical value is going to represent, because this is a left tail test, it's going to be the t-value that cuts off the, whoops, sorry about that. Cuts off the bottom 3%, okay? So let me show you the problem. If I go to table A3, here we go. They don't have a column corresponding to area in one tail is 0.03. So what we would have to do if it was up to us to find this critical value is we would have to use technology. So I want to show you how to do that real quick. I've gone over to my favorite website, StatTrack, which I am going to, okay, well, we'll just do it like this. All right. So t-distribution calculator, the random variable is the t-score. The sample size in this problem was 10, so I'm going to put 9 degrees of freedom. I'm going to leave t-score blank, and for probability that t is less than or equal to t, I'm going to put 0.03. Okay. So in other words, this will give us the t-score that cuts off the bottom 3% of the distribution. And if I hit calculate, it gives me that negative 2.15 that you saw on the PowerPoint. All right, I just wanted to show you where that came from because it was kind of a mystery. Not really the point of this problem, but still a good thing to know. So what would be the conclusion and interpretation of this hypothesis test? Well, before I click to go ahead, let me, kind of wish I had kept my picture here. All right, so there's my t-distribution. And now we know this critical value is negative 2.15. The rejection region or critical region would be the region to the left of that. Yeah. Doing all of this with a touchpad mouse. Sometimes I think it might be easier if I had a real mouse. Okay, so negative 1.82 falls somewhere to the right of negative 2.15, which is outside the critical region. So this is going to be a fail to reject the null hypothesis. Since the calculated test statistic is greater than the critical value, and this is a left tail test, we should fail to reject the null hypothesis, which means at the 3% significance level, there is not sufficient evidence to support the claim that the length of time patients wait between dentist visits is less than 180 days. There is not sufficient evidence to support that claim. All right. So that is the critical value approach to doing this kind of hypothesis test. In the next video, we will talk about the p-value approach, which is going to rely kind of heavily on technology. All right, so we'll do that in the next video, and that's going to do it for this one.